Good evening, everybody, and thank you all for attending what is now our 5th free community webinar. My name is Emma Virtual, and I'm the Community Liaison Officer for the MyTown Microgrid project or feasibility study. The two terms have been somewhat interchangeable. I'd first of all like to acknowledge that we are here meeting on the land of the Brayag people of the Gunai Nation, and I pay my respects to elders past, present, and emerging. So a little bit of housekeeping. Like I said, our webinars do tend to be somewhat interactive. However, I do ask that you remain on mute, and you can also kill your screen if you wish when our presenters are presenting, so we don't have any additional noise. Obviously, it's being recorded, so we like to keep the sound quality pristine for when we upload it onto our website. Can you please put your questions and comments in the chat? And obviously, we do like to encourage participation. So if you've got a question or a comment in the Q&A section, then please raise your hand with your Zoom reactions. Or obviously, if you start waving wildly, hopefully I'll see you. All right. For those of you who are joining us for the first time, a little bit of project background. So MyTown Microgrid, a 3-year innovative data-led feasibility study looking at the possibility of a town-scale microgrid or alternative local energy solution for the town of Heyfield in Wellingtonshire, which is where we are. So obviously some of you know this area very well, including Eden from Alice Springs, who grew up in Glengarry, and some of you not so much. So as well as obviously producing a replicable microgrid study, feasibility study, the project focuses as well on making it easier, cheaper, easier, cheaper, and quicker for other towns to engage with the same investigation. Back in 2020, when the study began, we received nearly $2 million in total funding from the Commonwealth Government and the Latrobe Valley Authority. Sorry, I'm just going to... with partners included. Sorry, can you just go back a minute, please, Heather? Thank you. We have multiple partners, including obviously our community reference group and the main partners, the Community Resource Centre, where I am based and sitting right at the moment, our technology partner, Watt Watchers, electricity network provider, and 3 universities, so being the University of Technology Sydney, Federation University, and RMIT. Again, the whole purpose of developing is to develop a novel approach, making it easier, faster, cheaper for communities to understand the microgrid proposition for their town. So as you can see, there's some nice pictures of us all there. All right. So what is the purpose of today? Well, this webinar accompanies the report, the initial feasibility results for a town microgrid, which was submitted as part of Milestone 4 last year as part of our reporting to the Commonwealth. So in a minute, I'll introduce our presenters from our technical team who will be really answering these questions. So what is a microgrid? What local information matters? What options are there available in Heyfield for both renewable generation, energy storage, and controlling and reducing energy use? And what were the microgrid results, and what is next for Heyfield? So on to my learned colleagues. First of all, Heather Smith. Heather is writing her PhD on redesigning the electricity system with microgrids. She is an electrical engineer with former careers in industrial energy efficiency and climate change policy. She has been working on 3 microgrid projects, this one in Heyfield, an off-grid system in Karula, and a resilience-based approach in Venus Bay. And Heather currently chairs the Coalition for Community Energy. She is a very busy lady. Dr. Soheil Mohseni. Soheil specialises in microgrids. He has a bachelor's and a master's degree in power engineering from his home country, Iran. In 2018, he decided to pursue a PhD in sustainable energy systems in New Zealand. This decision was motivated by the fact that New Zealand already generates over 80% of its electricity from renewable sources. During his PhD studies and postdoctoral fellowship at Victoria University of Wellington, Soheil developed a proprietary microgrid sizing tool and designed 5 microgrids for grid-connected and off-grid communities in New Zealand. And he is very busy packing. He is moving to Sydney this Saturday and to start working as a senior research fellow at ISF, University of Technology, Sydney. Thanks very much, everybody. And I will hand it over to Heather now. Thank you.
Thanks, Emma. And hopefully I'll do justice to all those questions and answer them to your satisfaction. So a lot of people, when we started, didn't have a clear idea about what a microgrid was. And in fact, a lot of people still don't. It sounds like a good idea. Although today we're all busy thinking community batteries are a good idea. So we've seen a couple of trends in the energy industry, and I fully believe microgrids will be part of our future. They're just not easy to do right away and all in one bite. So a microgrid can do everything a big grid can do, but just on a smaller scale. And the most important feature of that is keeping the lights on. So making sure that when people ask for energy, there's enough energy available anytime. And an important feature of that is that when the main grid disappears, you need to be able to rely just on the microgrid. So it's allowed to island itself, it disconnects. I'll go through some slides and show you what I mean by islandability. So when we say we were looking at a microgrid for Heyfield, we were looking at what would happen if Heyfield turned into an island and had to supply all its own energy. And before I get into my explanation, who has a microgrid? We've heard a lot about Yakandanda having a microgrid. They spiked their initiative as a mini grid, and it wasn't really a microgrid at all. It set up a number of houses to have batteries and allowed them to all operate independently at times if the power went out. So that doesn't really count. Malakuta, when it connected its battery so that it could seamlessly disconnect from the grid and reconnect when there are outages, and Malakuta's got a long 200-kilometre stretch of line that makes it quite vulnerable to outages. That apparently was the first time anyone in Australia had done that sort of microgrid. So that's a microgrid that is connected to the main grid most of the time, but it can operate in island mode as a microgrid when the main grid has failed. But most remote Australian towns that are not on the national electricity market are microgrids. And traditionally, they've all been supplied by diesel generators. Nowadays, they're increasingly putting solar and battery systems into those remote towns. So the same principles apply whether you're doing a whole community microgrid, whether you're just hooking in a backup generator occasionally, or whether you're doing what is called a standalone power system, which is what people who sell you batteries and solar at the moment can offer you, the fact that the battery could run your whole home and disconnect automatically. And so those mini standalone power systems are also operate on the same principles as microgrids. And of course, it doesn't just have to be solar and batteries. It can be single sites, small clusters of sites, or large clusters, or indeed the whole of Heyfield. So this is the traditional supply where a site or a whole community gets its energy from the grid through the meter to the house or the community. And increasingly, we've put solar panels on the roof. And when we've got so much solar, the power actually goes out from our solar panels and out onto the grid. So being connected to the grid is great because sometimes you're in deficit and you need extra grid energy, and sometimes you're in surplus and you can send that solar out to the grid and make sure it's getting used by someone. At night time, of course, your solar system doesn't work, so you're using the grid completely. Now, when you add a battery, maybe you don't need the grid, or maybe you only need it occasionally, because when you've got surplus solar, you can store it in the battery And if you haven't quite got enough solar, your battery can maybe supply your site or your community for the whole night, perhaps. At night time, it depends how big that battery is as to how long it lasts. In grid failure mode, you must disconnect from the grid. And that's got two elements to it. One is a safety issue. If the grid has failed because there's a fault out on the main grid and AusNet need to send their engineers to fix the fault, they don't want to be electrocuted by your power. So that's the safety element. But there's also an operational element. How would this backup generator know how much power to supply if you were still connected, your home or site was still connected to MAFRA, for example? Our microgrid would be trying to do the whole community plus. So this disconnection point starts to really define who's inside the microgrid and who's outside the microgrid, and boundaries become really quite important. The battery becomes, if it's not a generator-based system, and those generator-based systems used to be, you couldn't even connect the generator until you'd flicked a switch manually. But with the batteries are operating all the time, and so they're automatically detecting when the grid goes down, and they will disconnect automatically. And with the smartest systems these days, you might not even know you've had an outage because your power has stayed on with not even a flicker. One of your big issues is sizing up your battery or your backup generator or a combination of both, so that you know how long your outage might last and therefore how much you want to size your microgrid to be able to do. You might have a small generator and a large battery, or vice versa. Of course, if you've got a week-long outage, and some communities do, and of course this was one of the problems that the Malakuta faced, if you've got local solar, you can top up during the day. So what you'll see with a lot of battery analyses is they'll say, if an outage happened at any time, how long can I last? And they'll size the battery so it lasts 100% of any summer day, but it becomes really marginal to try and capture a week worth of bad weather in winter, for example. So there's a little bit of an economic struggle there when we do a microgrid. And of course, if you only do, so that was my big site, but if you only do your essential loads, so if you know you're on battery power or backup power and you turn a few big things off, like your air conditioning and your hot water system, you can last a lot longer in bad weather. So that's a sort of juggle that you can do as well. And essential to all of this is that smart control, because not only do you need to manage disconnecting from the grid, you've got an opportunity to optimize how much solar you might be getting, how fast or slow you discharge your battery, and whether you turn loads on and off to make sure that energy goes to its highest use. So recapping on the key things we're talking about here, a microgrid needs to know what it's serving, so it needs a boundary. The disconnection point will start to define that boundary. You need adequate generation. If you're going to be self-sufficient for any length of time, you need enough generation inside your boundary. You need adequate energy storage or flexible energy, and you'll see that in the example that we're going to give for Heyfield. And you need adequate control. So when you set out to do a microgrid in any community, and what we did in Heyfield was we gathered all the local information we were going to need. So boundaries and disconnection points were a key part of our information, looking at all the available local energy that we could do to get that adequate generation happening and how it could happen. And looking at flexible energy. So that includes storage, but in the case of Heyfield, it also included the fact that we had a timber mill with biomass. And if you're going to burn sawdust to make energy, you've already got your store of energy. It's called the piles of sawdust, or the silos of sawdust. And so that's actually a cheaper way to store energy than in a battery. And of course, the more we can do with flexible load, for years we've been told that the cheapest time to generate electricity is in the middle of the night. And so all of us have, lots of us have hot water systems that run at midnight. That's becoming one of the most expensive times of day because it's a peak load and the sun's not shining. So slowly we need to flex a lot of those loads into the times when there's surplus renewable energy. But first of all, you need to ask, why do you want a microgrid? So what happened in Heyfield was that we started with a vision workshop, and some of these themes came through clearly. People wanted to reduce energy bills. They wanted better reliability and resilience. They wanted to involve the community. They wanted environmental benefits, a more sustainable system. And they wanted to understand how much they could future-proof their system. And you'll see from here that a microgrid does a lot of these things, although there's a good chance when you get pretty good electricity supply from the grid, adding more assets and having to pay for them doesn't necessarily lower your energy bills. But there are other things you can do as well. And so a microgrid tends to need to do all of these things in one big shot: energy efficiency, load flexibility, batteries, renewables. You need to think about a retailer. There's also the option of picking off the things that you could start with or do first, or are the highest priority. So start with what you really want to achieve. That's my first piece of advice. The second thing we did was look at all the local energy options. Now, I've written against solar PV, diesel, and batteries that they're all scalable. Now, in Heyfield, we didn't consider diesel generators. You know, we weren't going to add that sort of thing. But it's worth noting that you can build any of these, any size from 3 kilowatts up to 3,000 kilowatts. So, so they're very scalable technologies, and the price doesn't change too much. In fact, when we looked at the solar PV, the price of doing a big system that connected directly to the grid was higher than one of doing lots of small systems on people's roofs, because you would have had to pay for the grid connection on the big system, and that adds quite a bit of cost. Biomass was a genuine possibility for Heyfield, but it's not for everyone. Wind biogas was one of the local resources. We didn't really talk about hydrogen, but that will be a storage option in future. And hydropower is genuinely an option around Heyfield because of the big Lake Glen Maggie has some hydropower on it already, and then there's a lot of that energy still running through the channels. It's, I mean, basically hydropower is capturing gravity, right? So you can capture more hydro energy as it comes down the channels. And this was the assessment. So we sized up one Heyfield, 26 gigawatt hours. And what you soon learn when you start to size the resources in a community is that you have an abundance of solar, you have an abundance of wind in most places. It's not necessarily a good wind resource. And Heyfield's wind resource was, wind loves high speeds, and Heyfield's wind resource is fairly persistent, but very much lower speed of wind, which means there might be some niche spots around the valley where it's quite good to capture wind, but it's a bit more of a hard sell. Biomass, you have roughly one Heyfield's worth of biomass there. So some of that is used by the timber mill directly for their heating, but that's a pretty substantial resource, and most communities wouldn't have access to that much sawdust. Biogas, this is a dairy region, so there's actually quite a lot of cows out on the flats pooping, and that's quite a rich source of biogas. There's all of the wastewater system for the town, and down in Traralgon, the wastewater system does have a biogas system on it, I believe. But at the size Heyfield's got, it wasn't worth Gippsland Water genuinely considering a digester on their site. And even if you added up all the people and all of the cows, you still only get about 3% of a hayfield out of the energy. So surprisingly, not a huge biogas resource. Hydro, the same. You've got about one hayfield being generated, not quite, maybe about a quarter of a hayfield being generated up at the base of Glen Maggie. Yeah. Very much determined by when people choose to irrigate, so when the releases come out of the lake. But in the channels, again, you'd be dictated to by when the water is flowing in the channels. And we're not quite sure. It would depend how many hydro turbines you put in every single channel, fill them up. It's not a huge resource. So that's worth noting. We didn't base our modelling on any of that, but we looked at these top three: solar, wind and biomass. We briefly considered geothermal, but it's not a very high temperature resource down in the ground. And I've put this little graph in the corner because right at the start, we talked to people about their preferences. And it's worth noting that there are always some people that don't like wind, so there's genuine things to consider about how people feel about big wind turbines, how people feel about burning wood, because there can be some environmental issues there, and how people feel about hydro, because again, these are your rivers and a resource that's also doing other things. So bear that in mind. And these were our benchmarks. This is where the one hayfield 26 gigawatt hours comes from. So this is a typical load profile. You can see at 5 in the morning, all the cows go to get fed and the timber mill starts. So quite a big peak there. You can see the hot water peak at midnight. Through the day, there's breakfast and dinner, and you can see that we're trying to build a microgrid for about 5 megawatts, 2.5 megawatts on average, and we've already got 2.6 megawatts of solar PV, rooftop solar, making a difference there. And this was our first boundary, right? So there are 3 electrical systems here. The pink comes from Traralgon. And this was a shame because there's some SWIR power lines, single wire power lines up through Seaton and over to Coongulla. And we really hoped that the Heyfield microgrid would support those people, but they're not even connected to Heyfield. They're actually connected to Seaton and Coongulla, are 2 different systems. And also the Glen Maggie power station, which sits at the base there, is not connected to Heyfield. But if we opened the electricity, made our disconnection point here, where the yellow pin is, we would get Heyfield and Winnendoo. Then we moved on to ask, well, do we want small or large clusters? If we went for smaller clusters, this is what you could do at low voltage. Every colour here, this is the centre of town mapped out with every different low voltage system on there. So every colour here, those people are connected together electrically. So you could disconnect at their transformer and you would feed everybody on that line. And one of the problems at this scale was we could either do the shops or we could do households over in this more residential part of town. But it sort of always served a mix of one or the other rather than everyone. And so with the community reference group that we're working with, we decided to stick to a bigger system. Reliability was one of the things we were concerned about. And so we actually chose 2 disconnection points, that one I showed you earlier and a second one that would Winnendoo, because the more lines you have in your microgrid, the more likely it is that the fault, the thing that's causing the outage in the electricity system, will occur inside your microgrid. So lines are prone to storms, they're prone to weather. And when you look at the outages for Heyfield, they had a very rickety time for many years because they've got so many sawmills and really tough electrical loads. But AusNet had done a lot of work here and things had been improved a little bit. So most of the outages were local outages. There weren't an awful lot that affected the whole town. So that was the boundary we ended up with for our microgrid. And the reason we didn't go smaller than that is because this is where the timber mill is. So we wanted to keep biomass in the mix. And if you did put in wind turbines, you wouldn't be able to put them in the centre of town. So we needed enough space around the town. This is actually on a little rise and the wind comes flying up the Latrobe Valley. So if there's anywhere that's ever going to be useful, that might be one of the spots. So, so that's those locations. We did some technical modelling. Federation Uni did some technical modelling to look at electrical currents and what the maximum current the electricity system here could take before reaching its thermal loading and things like that. So without impacting on the reliability of the system, almost 12 megawatts of local generation can be poured in. You can export up to 1.6 megawatts before you start to get voltage problems. So you'll see that that starts to be a problem when you'll see the size of the solar that you need to fully do this system as a microgrid. The microgrid could provide some improved reliability. You've still got a problem with your reliability modelling that some of the faults occur inside your system. And we, in our modelling, put half to $1 million in every scenario to allow for extra switching that you would need on the medium voltage system. So you're going to have to automate this switch here and automate the switch on the Maffra Road coming in. Both of those need electrical infrastructure and investment in that sort of part of the microgrid. That's even before you start doing storage and generation. So it's a bit of a sunk cost on a microgrid and it starts to kill things. If I reflect on the Malakuta microgrid, they got $7 million from the Victorian government, I believe, and they got a second-hand battery, so they weren't even buying a battery for that money. So an awful lot of investment just for that, just for disconnecting. If your aim is self-sufficiency, you can do that without building the microgrid capability, that islanding capability. And we also looked at the RMIT looked at the regulatory feasibility and reminded us that if you want to do this, you're either going to have to convince AusNet to do it for you because they own the poles and wires, or you're going to have to lease or buy the poles and wires from them and get yourself a distribution license, which is not a trivial bit of work. You're going to need a generation license because you would have more than 5 megawatts inside your microgrid, but that's the threshold. So some microgrids would be smaller than that. You will need a relationship with a retailer or your own retail license. And because electricity is so heavily regulated, you can't do it without complying with a bunch of consumer protection laws, as you would expect, right? If you have captured a whole lot of people inside your boundary, there are consumer protection laws that say they need to be allowed to go to the market and buy electricity from anyone. They can't be forced to buy it from you. And you need to make sure they're not paying more than they would be paying in the normal electricity market. So quite a lot of challenges. And with that, I'm going to hand over to Soheil.
Thank you very much, Heather, for setting the scene. Hi, everyone. So I'm going to be talking about the economic feasibility results. We've done the analysis in Homer. Homer is an economic viability assessment model, and it searches for the cheapest long-term option. So it looks at all your loads, your houses, your businesses, your existing generation, and your potential generation, and tells you how you can meet your load and what's the best mix of importing from the grid and putting in new generation and new storage, and what's the cheapest for the whole system. And so it looks at the microgrid as one integrated whole. And a key decision that we made early on was to do the analysis with and without bioenergy, as Heather said, to see how would the microgrid work if the timber mill is part of it, and how would it work, if the timber mill is not part of it. And the reason that we wanted one with bioenergy was because it's a very large generator, and it's also dispatchable. So it's likely that it would come out more economic by complementing PV generations. It is really important that the bioenergy plant is operated in an entirely integrated manner, and that's why it is likely to be the cheapest option to have it in the mix. We also looked at a scenario without bioenergy because, number one, not every community has a timber mill. But also because the community might not, want to, attach all of the town's fortunes to one particular business, and might not be able to control the bioenergy plant. And of course, whenever you have modeling, you make a lot of assumptions. So we tested the robustness of the results against 3 assumptions that we thought would have the most impact on the costs. And we tested some high and low values, and they were these. Number one, what amounts do we have to pay for the electricity network, and also how much is the bioenergy plant is, how much the bioenergy plant is going to cost, both in terms of capex, capital expenditure, and fuel costs. Next slide, please. And here are some of the early learnings and modifications. Initially, when we allowed the model to import from the grid without any restrictions, we found that that would lead to a significant amount of imports. So we introduced import limits to ensure that the system is not overly reliant on low-cost imports. We also considered wind and centralized PV in the initial simulations, like Heather mentioned, but they were never found to be cost-effective for Heyfield. Centralized PV, for example, is never cheaper than rooftop PV, so the results kept giving us more and more rooftop PV. And Homer wasn't the only thing that we did, because it cannot calculate some of the things that we needed to know. So outside of Homer, we did additional calculations, and especially we looked at what the implications of a microgrid are for energy bills and OSNA services income. Next slide, please. And here are some of the key inputs. First of all, we have not assumed any capital cost for the current network, because that would be multiple millions of capex or capital expenditure. Alternatively, what we did was that we assumed that the OSNA services income needs to be maintained, because obviously they own this asset. And we calculated the OSNA services income as approximately $1.2 million. So we started off by using that as the network lease cost. And we then realized that it didn't need to be so high, because they still get income from imports. So we calculated what's their income with the lease cost and the microgrid import is. And we looked at 2 lease costs of $0.6 and $0.9 million. And we finally realized that with the lease costs, it's actually the higher limit that works. So that's pretty much the results that we're presenting today. And for the bioenergy capital expenditure, we assumed $4 million for a 2 megawatt system as the lower limit, and also $8 million as the upper capital cost. And these values are assuming that the system is installed at the timber mill. So some of the equipment that would normally be needed is not needed here. And we must say that the $8 million is a more realistic assumption and fits better with the literature. And for the biomass feedstock costs, we have assumed quite a wide range for what is available from the fuel. The $19 per ton is the lowest value of sawdust that you get in the literature. when it's not just pure waste. So the $19 is definitely on the cheap side, and it would definitely only be for own use. And the $60 is the current estimate of what you can get from high-grade sawdust, such as that of Heyfield's timber mill. So $60 felt like a reasonable amount to look at the high end. And all the other values are other assumptions that we've made. I'm happy to talk about any of those if you're interested later. Next slide, please. And here are our main results. Let's start with the scenario without bioenergy with an import limit of 2 megawatts. So it says that adding 2.5 megawatts of rooftop PV along with 1 megawatt hour of battery storage provides a local supply of 47%. So it represents a self-sufficiency of 47%. But this is obviously not the percentage of local supply we're looking after, because it is not much more than what it is already today. So if we lower the import limit to 1.5 megawatts, that gives us a local supply of 71%. Well, that's better, but probably it's not enough. So let's reduce the import limit further down to 1 megawatt. And that gives us a local supply of 94%. But that comes at the cost of curtailing 37% of local generation, because we have an export limit of 1.7 megawatts. And in this scenario, we also need to install 16 megawatts of new rooftop PV and 26 megawatt hours of new storage, which makes this scenario very costly indeed. And this is really a big value both for solar and for storage. For example, just to give you an indication, the Malakuta community has just recently installed 1 megawatt hour of battery, and so 26 megawatt hours of storage. It's insane, and I know no way to finance it. And but on the positive side, 26 megawatt hours of storage provides approximately 12 hours of battery autonomy. And this means that with the battery itself or alone, you can sustain the loads for about 12 hours. And this is, of course, a significant resiliency benefit, but it's not realistic from cost perspective, really. And the battery autonomy is much lower when we have 7 megawatt hours of storage. It's actually just about 3 hours, and it is as low as half an hour with 1 megawatt hour of storage when the import limit is 2 megawatts. And now let's focus on the scenarios with 2 megawatts of bioenergy, which is our most promising case. For example, in the case where bioenergy costs are high and the import limit is 1.5 megawatts, which means that it will be a bit cheaper. A higher import limit makes the whole scenario cheaper. And but you can see the curtailment is really low. It's only 3%. That's very small, and part of that is because we only have a small amount of added PV. So it's an extra 5 megawatts, and also we only have a small amount of new battery, only 1.5 megawatt hours. So of course you'll get a very low battery autonomy compared to, in comparison to other scenarios. It's just less than 1 hour, but that can be okay, because especially for short-term outages, and like Heather mentioned earlier, if turn off the big loads, it will get much higher. You can sustain the loads for an extended time. But for all of the cases with bioenergy, generally the curtailment is really low. We're looking at curtailment between 1% and 6%, whereas we're looking at curtailment between 13% and 37% in the ones without bioenergy, with import limits of 1 to 1.5 megawatts, which gives us, reasonable amounts of local supply. Next slide, please. And Now let's see what the implications of a microgrid are in different scenarios. And this is probably some of the most important results from our analysis, as it indicates what this means for people's bills. These two on the left are showing the estimates of current bills for average households. So the blue square is the average households that don't have solar, and the orange circle is the average houses that do have solar. So obviously the houses with solar have much lower bills because they use electricity from the grid and they get a feed-in tariff. And then let's look at the microgrid without bioenergy first. So for an average household with solar, this means that bills can go up by over $700 per year. And for average houses without solar, they can go up by circa $900 a year. So actually, without bioenergy, both average households with and without solar are affected very badly. And obviously, this gets even worse for bigger houses. And in the scenarios with bioenergy, generally houses without solar are better off, and the houses with solar are worse off. And this is mainly because houses with solar lose their feed-in tariff. And the only scenario where both houses with and without solar are better off is the scenario with bioenergy, where we assume low bioenergy capital cost and fuel costs, and the import limit is 1.5 or 1.5 megawatts. But where bioenergy capex and fuel costs are high, which is a more realistic case, bills go down only for residents who don't have solar installed. And if you want to look at the interactions of the system and the system dynamics, next slide, please. You can see that here in this slide how the dispatchability of the bioenergy is complementing solar generations. So for this indicative high solar generation days, you can see that it's still the bioenergy plant still needs to run at full blast in the evening and nighttime. And in low solar generation days, they need to run for almost the entire days. It's in some cases, which is probably not good at all, because they might need maintenance, and they also reliant on feedstock availability and so forth. And so you can see that here you really can get some sense of why it can be really risky, to attach the entire system or to heavily rely on the bioenergy plant and to make the microgrid. And because that was the case which was giving us the most cost-effective results. And next slide, please. So this is the detail of impact on energy bills. So as you can see here, there's only one scenario that everybody is somewhat better off, and that's in the scenario where we have absolutely the lowest cost for bioenergy, which is a big assumption really. And the other thing is that, and the other important thing to look at is the total capital expenditure. So the costs of scenarios, they're ranging between $15 million and $50 million. So it's quite a lot of expenditure that has to go into this. Next slide, please. So to come to the conclusions, first, scenarios without import limits indicate low local generation and low self-sufficiency in turn, because importing energy is generally cheaper than storing local energy. And also, curtailment is found to be so high in the scenarios without bioenergy, but it is relatively low in the scenarios with bioenergy due to the dispatchability that it provides. And in the scenarios without bioenergy, they are not economic, especially that because they don't provide a significant network benefit. But scenarios with bioenergy may be economic, as we saw, but they require the bioenergy plant to be operated in a fully integrated manner into the system, which is associated with significant risks. And the main risk factor here is that it should be treated as the central element of the microgrid to make the system economically feasible. And finally, the initial capital expenditure is high, so high in all cases, from $15 million to $50 million, which makes financing the project challenging. But all of them don't mean that you shouldn't start, the microgrid journey, because there are a lot of things that you can do as the enablers of the microgrid, which are the local energy solutions that we've explored in the next phase of after studying the microgrid and finding out that currently it's not, economically viable. We decided to, in a co-design manner, as a joint decision, we explored some complementary local energy solution options. And I would like to ask Heather if she can provide some details on them.
I won't go into detail about these, but obviously, once the reference group had sort of considered how much of an undertaking continuing with the microgrid would be, and maybe not choosing to bite off the whole project all in one go, we've started working on community battery projects. So actually, they're going to look like microgrids, but at the low voltage level, and there's going to be more than one of them, sort of thing. And we looked at load flexibility and control, because part of your problem with those 16 megawatts of surplus solar just to match your local generation is that if you can put your hot water, particularly in the middle of the day, you can soak up a lot of that. And that's going to be a perpetual problem across Australia, that we have surplus solar. And the other things we put to the community were doing a large-scale renewable generator, and supporting Ash, the timber mill, to do their biomass generator might be the way that ends up starting. Looking at energy efficiency, because you can always justify doing energy efficiency, and investigating how to go ahead with retailing, because any of the solutions, you need to know what electricity retailer you're going to work with. And so some of the outputs, the techno-economic modelling is on the website. We've developed a decision support tool to help people get an early read on whether a microgrid makes sense in their location, and numerous other things they can do as community energy projects, depending on what their values are. And some of our other feasibility results are there as well. And I will hand back to Emma.
Thank you very much, Heather and Soheil. That was fascinating. That was absolutely brilliant. Okay, if you can just stop sharing your screen, Heather.
Oh, yes, of course.
That's true. Probably can. Yep, there you go. Fantastic. All right. We still have a lot of people with us, so we haven't got rid of them.
Yes, they haven't fallen asleep.
All right. I noticed there are a few questions coming up in the chat, so we'll start off with them. Ash, I believe you had your first question around geothermal.
Yeah, so let me just do a little bit more on geothermal. Geothermal is a huge resource, but it's probably sitting there at about 70 degrees. We did a number of things. We tried to work out how much it would cost to drill for geothermal. That wasn't there wasn't an awful lot of information about that, but that's going to start to define the size of your project that you need, so you can justify drilling a big hole down to the resource. Soheil over in New Zealand, some of that 80% of renewable energy they use in New Zealand is geothermal, right? It's the land of hydro and geothermal, both of which are dispatchable sources of renewable energy. And we're sitting in the land of solar and wind, we're both of which are variable. We also compared the idea of using the heat in conjunction with solar thermal or biomass. So if you've already invested in a generator that can convert heat to electricity, like a biomass one or a solar thermal one would be, is it worth trying to get geothermal to boost that? I think it struggles to even compete with solar thermal, but it would all depend on how cheaply you can pull it up in the first place. 70 degrees is not great. So that's the geothermal story. But yes, definitely we should take you up, Ash, on some more information as the Geothermal Innovation Network get more evidence and information, because there was not a lot around 2 years ago. Someone has asked me about the efficiency. Alex, are you happy with that answer, Alex?
Yep.
Yes, great. Good eye.
Does it? Oh, good. Ian's comment.
Ian's asked about the sawdust pricing. Yep. I think in hindsight, the challenge, yes, we included the wet sawdust because to get the volume, we didn't constrain the amount of sawdust that was available, and the wet sawdust doesn't burn as efficiently, so we would need most of that resource. The main improvement I would make to the modelling now is to make the biomass plant more expensive, because fewer went on after we'd done the start of this modelling. Fewer went on and did a whole study for the timber mill, chasing the gas turbine that had been sproiked for $2,000 a megawatt. And I think they came closer to $8,000 a megawatt by the time you do all the work on site to accommodate the plant. So I think time will tell whether that exploiting that biomass is a good idea or not. But first and foremost, it'll be the timber mill that thinks about where they can get the highest value for their sawdust.
Yep. Okay. Thanks. I'll probably bring that up privately with you, Heather, off air.
Yeah, happy to have a chat and double check how much we looked at that wet sawdust, because obviously it is a resource,
no,
and
definitely.
it's less valuable.
Yeah, thanks for that.
And
question from Wendy Palmer. I think that was it. Was that on there? Yeah.
if the regulations change for microgrids and being able to connect to the grid, do you think there would be more opportunity for microgrids? Wendy, I think this community battery trend that we're following at the moment is really going to break down some of the regulatory barriers. And I think a lot of them are pricing barriers that the networks are forcing us to pay for the whole network every time we put electricity on the little part of the network where my surplus solar goes around to my neighbour. And the community battery discussion is forcing them to reckon with, actually, local energy is cheaper and we've got local problems that we need to deal with and we need to incentivise those. And I do wonder when we start to talk about local system charges and things, whether we will start to talk about local markets, and that will really break down this this regulation that's all about helping everyone access the big wholesale market, which is ridiculous at any cost, which is ridiculous because we actually want to solve the problems locally over and over again. So yeah, a lot to be had there.
Another question from Alex. It would seem that existing domestic rooftop PV is making microgrids less economically viable, or is that more complex than that?
I think, Alex, one of the challenges with this sort of modelling is not knowing what is that when you start with your existing load and just a dumb, let's generate as much solar as possible approach, and I'm in South Australia, right? So South Australia's domestic PV has powered the whole state a couple of times over the last couple of years, right? So that means on one day a year, the whole state is powered up from rooftop PV. So you can see that the more rooftop PV we put in, yeah, it fixes a lot of energy consumption the rest of the year, but it starts to get thrown away. So if we model a dumb system, dumb load, dumb solar, we get expensive outcomes that the national electricity market is desperately trying to price correctly, and it's all a bit of a game, and I don't know how much we're meant to believe that wholesale market prices give you true pricing for what the future looks like. So I think if you can feel confident about how to use your solar, your microgrids become much more valuable, because those sort of elements to do the flexible load and the flexible nighttime generation and the emergency generation, all those little bits that the microgrid does extra become way more valuable, because you're not over investing. You're not doing 26 megawatt hours of battery when most of the time you can do it with one and solve a whole heap of problems.
Okay, all right, so one person's headed off. Any other questions at the moment? I mean, it seems just from my observations, my non-technical observations, the importance is almost being microgrid / renewable energy ready. So if we're going to optimize what we're generating, we obviously need, I don't see it like a really sort of dumb thing to say, but you need to be really smart about how you are managing your load. And that's probably the biggest lesson. Going back to a comment that Ash made further in the chat around, you know, just those small steps, and that load flex is clearly the first step, or one of the first steps.
And I think, you know, so far we've rushed out. Every new solar panel's been a nail in the coffin of coal-fired generation. We've pushed the system to that limit, and now we're having to solve the problems at a system level. So the individual stuff, and that's harder for communities, because communities could do a lot of those smaller projects totally within their sphere of influence. And now when we're grappling with what's the right system to have, you do have to work with retailers, you do have to work with the network companies. And that's the challenge in front of all of us. And I do think forms of microgrid style self-sufficiency is going to be a really powerful part of what we all build locally and showcase to everyone else.
Yeah, okay. All right. Has anybody got any other questions at the moment? Any other comments, questions, things they'd like to share? Let's see. Oh, Ash, yep, go on.
I just said I'd say it instead of typing it out. It's more in the just thinking a bit more broader around, you know, building resilience and being a showcase town. I wonder if that has, you know, what are the economic opportunities that might come from businesses that say they want to be green and they want to do, you know, run their business through renewable energy. If you had a system that was set up that was practicing that, I wonder what the you know, competitive advantage might be for Heyfield. Where does that make sense? So there's, you know, people want to come and live there because it's has renewable energy. They want to shop there. They want to start their business there, with, you know, which is a big plus. It's not a, it's probably a comment actually.
Well, South Australia tried that, and we got a billionaire to come and buy our steel mill. And he wouldn't have come and done that if it wasn't for his view of the green steel is going to have to be highly renewable. I mean, you can't put a price on that. Whyalla was a town of 40,000 people. It had dropped to 20,000 people. I'm sure it's still in decline, like everything's automated these days. But there's a genuine, deep possibility, and I guess South Australia's definitely been pursuing that at a state level. How it plays out at a regional level, we know some regions find it at odds with their brand. So some regions are clean and green, and that's their tourist brand, and so you know, being renewable is important for their brand. Being non-renewable can really pour cold water on their brand, if you know what I mean.
Okay. All right, there was a comment in the chat from Chris Harvey.
Chris, would you tell us a little bit more about the co-contribution model? Because I don't think I know what you're talking about, but it sounds interesting.
Yeah, hi Heather, how are you? Well done to you and Soheil for the presentation tonight. Excellent.
Thanks.
Yeah, so a couple of us on this call are on AusNet price reset panels as part of stakeholder groups. And there's a number of interesting innovations being raised at those panels. This is a process going to take a couple of years leading up to their next price submission to the regulator. And it's well understood that communities are more and more expressing needs for local generation and local systems enhancement. And AusNet well and truly recognise this, and it's very much on the agenda for the panels to be thinking about other models for how payment for these systems will occur, or will be, I guess, how it will be paid for. So there's a potential, for example, if a community wants a particular enhancement on their network, that there's some level of co-contribution from the community to that project. So very much just a concept recognition at this point in time. A lot of water to go on what that might or might not mean, but I'm just I've taken the opportunity, given that you raised it, to say that there are some innovations being discussed, exciting innovations.
Yeah, that's really interesting, because with the community battery approach, batteries have the opportunity to contribute in that they can earn revenue. And so maybe that's one of the things they're thinking of, is being able to put batteries out in communities if they don't have to pay for the whole thing themselves.
Yeah, correct. Well, it's quite clear something needs to change with neighbourhood batteries for them to be deployed other than by whole, basically fully paid for by government.
Yeah.
And so, I think all the players are sort of pondering at the moment different models of how we make this happen.
Yeah.
Which is great.
Thank you for that, Chris. That's really good. Simon, you have your hand up.
Yeah, thanks, Emma. Heather, Soheil, great preso. I love it. Such brilliant work. It really is. So it just cuts through the bullshit, really, doesn't it? It's fantastic. I thought I'd just share. For those who haven't met, I'm part of the Institute for Sustainable Futures team on this project, and very delighted to be involved. In a unrelated project, we have been doing an evaluation of about 20 of the federally government-funded microgrid projects around the Eastern Seaboard, and I just thought I'd share that to give a broader context. It might just help everyone's understanding. It's quite apparent that microgrids are sort of not in their infancy, but this rebirth of microgrids is sort of still in its infancy. And we looked at particularly remote Indigenous communities, other remote communities, and also communities that were very vulnerable to bushfire. And none of these microgrids stack up financially for lots of similar and also different reasons. But a lot of what these microgrids brought to these communities, there's immense amounts of value that perhaps isn't captured in traditional economics. For some of these indigenous communities, as I'm sure you can imagine, yes, it definitely gave a foundation for energy resilience, but there are also far greater outcomes. We know that these communities are consuming 30,000 litres of diesel a day, for example, on these antiquated diesel generators. And so they're storing obscene amounts of diesel, which is such a hazard for them and their community. There are all sorts of benefits in terms of hot water, which cascades into better health outcomes for these communities, allowing people to access power, the internet, to facilitate job searches and all these things that we will take for granted, and I'm sure you know. So I guess the economics at the moment are pretty tough, and the regulatory environment is antiquated, and the tariff environment is complex, and sometimes I get out of bed and probably like, heavens, how do I bang my head against a brick wall with all this? And go, come on, guys, get with the show. But the reality is we are in this amazing period of transformation, and things are transforming. It's taking time, but microgrids remain a really, and I think Heather was alluding to this in her final comments, microgrids remain a really critical part of the energy jigsaw for a lot of remote and regional communities. So I just wanted to share that perspective, comparing it to some other projects, and to hopefully conclude my comments with quite a sort of positive and optimistic note of the potential for microgrids to have real impact in the right contexts, in the right situations, depending upon the benefits that you're looking for. But the one thing that our case study review taught us was that every situation is different. And so, very context dependent on where the community sits on the network. Most of them are obviously either at the end of a network, or just so remote that they've always been reliant upon these antiquated generators. So yeah, I hope that's useful. Just thought I'd share that because it's related, unrelated. Yeah, thanks, Emma.
Thank you, Simon. And all I can see is lots of nodding heads and thumbs up. And I mean, I think everybody, well, not exactly preaching the converted, maybe, because this is, my mind, this is what community energy is in terms of actually defining something by a non-monetary value. And like I said, how it's really hard to actually put a value on health, except obviously we know the cost to our society for, communities that are so badly served by their power, and then the impacts that has. We have multiple levels of disadvantage because of it. So thank you for that.
Sorry, Emma. Oh.
Sorry,
could I just ask Simon a question? Is that all right?
Yeah, of course you can.
Yeah. So Simon, I'm just a bit curious that where you see all this, the renewables, community batteries and all that sort of stuff going, given that the fossil fuel industry, I mean, it gets the most obscene amount of subsidies and whatever. So you could hardly call the fossil fuel industry as a good business model anyway. So I'm just kind of a bit confused now about how renewables fit into the fossil fuels, given they've got massive subsidies anyway.
Yeah, that's good.
Oh yeah, look, we know the fossil fuels industry gets about $26 billion a year in direct subsidy, let alone indirect subsidy. But look, I think all of those elements will be a critical part of our energy transition, and the economics will work themselves out. There'll be, Soheil and Heather, you guys are the engineers. I'm just an energy jack of all trades, who happens to have quite a PhD in this stuff along the way. But I think that these things will attain economies of scale. They will force regulatory and tariff changes. They will fit in some instances and not in others. And so they will be a part of the overall pie. But the distributed energy future is going to look very different from this sort of centrally generated and distribution future that we've had for the last X years. But I think it's going to happen. It's all going to happen very, very quickly. It is happening very quickly. And these are, we're all backing the right horses here. There's no question about that. Fossil fuels is yesterday's story, albeit it will remain part of the energy landscape for some considerable time, particularly in terms of, gas transitions. We still don't have, we can electrify homes pretty quickly, at least in theory, but we have some big industrial users that we've got to wean off gas. So, gas is an issue, not least because we export most of ours overseas at inflated prices. So, but we're all backing the right horses here, and this transition is going to happen. It's going to happen super quickly. But equally, I think Heather and Soheil have done a fabulous job of highlighting all of those things you really need to think about. And in this context, the potential of biomass to really change the rules of the game. Certainly where I live in the central west of New South Wales, biomass too is we did some biomass mapping a few years ago, and it can play a really important role in our clean energy future. And we're seeing some interesting biomass projects down in Cowra, where you have sort of biomass, solar and storage as a potential solution for an industrial precinct. And I'm doing some work with New South Wales government on their special activation precincts in Parks and Wagga, just around the traps here in New South Wales. And again, each will have their own solution. But Mike, we're definitely backing the right horses here, if that's the question you're asking.
Yeah, I'm just not sure why renewable energy has to be an economic solution when I just don't see the fossil fuel industry.
No, totally. Look, absolutely right. Yeah, I think this notion, if we just step away from it, you're absolutely right, 100%. But I also think if we step away from this ridiculous notion of free markets, virtually none of our markets are free markets. Every market has some form of subsidy, or direct or indirect, and that there are very, very few free markets. Those that are free are
and picking up on that, so Murray's mentioned the role of retailers and the role of networks, and we've got to remember that the networks were designed around the old centralized model. So what we're seeing, they're not really a market, they're a monopoly, but what we're seeing is the crunchy, difficult structural change that needs to be forced on them year after year as we push them through change. Whereas the retailers are a bit more of a free market. So they're already attempting competitively to solve problems. But you find even in the retail market that the big guys are not very innovative, and it takes the little people around the edges to really showcase the ways we might go forwards in electricity retailing. So I think they're all, change is hard. I'd like to pick up on what Ian has pointed out about Lukola, and maybe ask you to reflect, Simon, on whether you said, no, you had a throwaway comment about the microgrids you looked at not being cost effective, but surely they were for getting off diesel, or were they trying to do 100% off diesel when they would have been best off keeping a little bit of it?
Yeah, precisely that, is that there were some fairly big aspirations, and it was more about reeling those back in. But absolutely, at some point, they would definitely break even. But also, in other jurisdictions, of course, there are slightly different laws, and here is the regulatory challenge is you have network service providers still trying to stay in the game and slow the innovation, and that too is a challenge. You see in Queensland and the Territory where the network service providers are trying to play that game, but they're almost tying the hands of the innovators behind their backs. And so it's but absolutely there were definite break-even points, and we need some Heather and Soheil analysis in each of those feasibility studies to provide that point.
Absolutely.
Ian, you've taken yourself off mute. Were you going to say something?
No, I'm fine. I just wanted to make the point, without the generation, other than solar, you're in trouble. You've really, as Simon just said, you've got to run your diesels, or you've got to have something that you can use it as an extra generation asset. No, Simon said it.
In my Arkarula project, which is off-grid, I modelled wind and battery, and I could have one or the other. So they were roughly the same cost, and the value of both of them was that they worked at night, and neither of them did the whole thing that the diesels do. So I'm still stuck with a little bit of diesel, but it was really interesting that we have to remember, if we diversify our renewables base, you cover more of the hours of the day, and that has quite a lot of value.
Just one thing about wind. It's a thrown around number, but basically 20% of the rated value of the wind turbine is their average production. And that's not real good.
Yeah, definitely.
Thank you. Wendy, you've made a comment there. Did you want to add in the chat? While governments back big international companies to supply our energy, it will continue to be hard for community energy, but we can change that by pressuring our state government and being involved in designing and inputting into Vicgrid and the new SEC. Would you like to make any further comments around that?
I just think that, you know, we need to continue putting pressure on the Victorian government to actually look at the value of the social impact of community energy. And we've got opportunities with Vicgrid, we've got opportunities with the SEC. We've had our Premier say that he's going to be hands-on for energy. So let's make sure that we can be part of that and put that pressure where it's needed.
We had a very interesting development as well today, didn't we, in terms of the Delvin wind farm. So the go ahead for that, that's full steam ahead?
Yes, so that was under a challenge by the Supreme Court and thrown out on the, or well, blown out of court with the fact that it didn't go against any planning. And, you know, it was, the judge had noted in the court case how ironic it was that how close the mines were and the power stations to the urban centre of the towns, yet we were arguing about, you know, 0.x of a kilometre on a wind farm. So yes, we had a win today, and that will go ahead and start being built 2024.
So that's a huge step forward in terms of onshore wind. No,
I think there's a big challenge price-wise to transform the way we use our energy. And I suspect that flexible load is going to be like energy efficiency. It's going to be a market failure. The commercial players are not going to want to deliver it or deliver it in the depth that it needs to be delivered, because it's not a particularly expensive thing, but people need to understand it. So all of your costs are in time and effort, helping people understand the new way to the new way our electricity system needs to look. And so I think the Vic government can't do it without communities, but that needs to dawn on them. I don't know how big that summer solar peak has to get before it finally dawns on them.
Exactly.
do you think part of it is so we're used to very well, we obviously used to centralized generation and instant switch it on and it's there consumption. So is there a problem there in actually sort of turning around to individual behavior? Is that a big change there, or do you think we are going to be able to sort of just set it and forget it? Is that, you know, do we have the rollout of enough smarts to manage populations in that way?
I just think the cheapest game in town is wind and solar, and we're letting communities down if we don't help them use wind and solar. So you will end up with expensive things filling the gaps if we don't work out how to help people get the cheapest energy.
Everyone's far more conscious about the cost of their energy now than the cups were even when we started MyTown, when MyTown started, that, you know, the prices have gone up. So we're more interesting, aren't we now, because of that change? Yeah. Okay. All right. Does anybody have any other questions or comments or feelings you'd like to share? All right. Okay. Well, with that, big silence, what do you think? I think I might say thank you very much to everybody for attending, and a massive thank you to Heather and Soheil for delivering a fantastic presentation. Obviously, for some of us who have, we've been on board, so we've been listening to this, but I always learned something new. And Eden, oh, that's right, I wanted to, not necessarily the right time to ask you to talk about this, Eden, but Eden is beaming in from Alice Springs, and you're working on another Institute for Sustainable Futures project, the Alice Springs Future Grid, is that right?
Look, yeah, thanks for the query. I was working on one aspect of what was a big project. I've since wrapped up on that role, but obviously, fascinated and super excited about that that era of change that we're in. It was predominantly, there was a host of different activities. There is a small microgrid trial that's intended to prove the concepts and the cases and then be rolled out in other fashions. My particular role was around virtual power plants and just seeing what role they could play in, I guess, the grid of the future. And it was a multi-technology mix. So rather than the Adelaide scenario where they were aligning to a relatively small number of providers, we allowed a whole host of inverters to be part of the mix, and that has been providing some good insights. And if anyone's interested, I think the technology provider we went with was called Switched In, and so there's a lot of innovation happening in that space at the moment. I think we're all looking forward to the stage when the findings are coming in, and we can share that with the community and all the other people that are doing interesting studies out there.
Thanks very much for that, Eden. Obviously, we hope to hear what your results are and obviously learn a little bit more from the Alice Springs experience. Definitely.
I'll certainly flick through the details of the project and the project director for you to take that opportunity further. And anyone is welcome to learn more. I'm sure there'll be some online seminars like this in due course.
Yeah, fantastic. Yeah, I do follow you on Facebook, and it's all pretty fascinating. Okay. All right, so this is definitely my last comment, my last thank you, and my last goodbye. Again, it was fascinating. Like I said, every time I learned something new. So anyway, never gets bored. Thanks very much, everyone. Thanks for joining.
Bye.